Hey there, welcome back. So in this tutorial, we're going to do a quick hands-on demonstrations of how to do a contingency analysis in PowerFactory DigSilent. Great. So if this is the first time you're tuning in this part 2 of this tutorial, I recommend watching part 1, where we cover the basic theories of power system contingency analysis. Great. Now that you are here, let's dive into this practical demonstration. So to do contingency analysis, you need to have a power system network, as you can see here. So this is an example network from DigSilent PowerFactory software. To open this network example, you need to go into help and start tutorial. Then you need to click on start and select tutorial number 6. Right, then it's going to open this particular tutorial for you, and you can run a load flow analysis as I've already done here, right, so that you can basically see, and that will give you a good understanding of the power flow in this particular network before you can run a contingency analysis. Obviously, before you can do any contingency planning on your power system network, you need to understand exactly what your network is made of, right? We can see here we've got how many generators here. There is a synchronous machine 1, there is a synchronous machine 2, and there is a synchronous machine 4. I'm not sure if there is a synchronous machine 3 here. I don't see any, right? But we've got a single transformer here that's converting from 110 kilovolt. That's a potential of this bus bar, and it's stepping it down to a 33 kilovolt, so we can potentially connect some outgoing feeders or loads in this bus bar, right? And then the rest of the bus bar here, they're basically running at 110 kilovolt. Okay, so that's the potential on all these bus bar here, and obviously these lines are also running the 110 kilovolt transmission line. So you need to understand your network, and that will empower you to plan better and do your contingency analysis. It takes 3 steps to generate or to execute a contingency analysis in DigSilent. So first we need to define our contingency, and then we need to set a loading or voltage limits, and then we're going to analyze the report. Okay, so to set the contingency definition, this is the icon that we need. So if you don't see, just click on the green icon here and select your analysis name. So we are on contingency analysis, and we're going to click on contingency definition. Great. Now, as you recall, on part 1 of this tutorial, we talked about the outage level n-1, n-2, up to n-k, and k being the number of generators or lines or whatever you want to basically simulate failure in your power system network. So if you select n-2, obviously you're going to have a lot of stuff to deal with. Basically, you're going to have a lot of numbers of contingencies that you're going to be dealing with. So let's just try to quickly see how many contingency level we're going to have if we select n-2. There you go. We've got about 153 contingencies that will be created and analyzed. So if you say yes, obviously, and then you say show, right, these are the numbers of all the contingency, and basically PowerFactory is going to go and run and analyze all these in the background and give you a report. Okay, but now let's just go ahead and close and go back to the definition here, and we're going to select only n-1 here to basically simplify things here. Okay, and in terms of your network component, you can select to create cases for the entire network, or basically to select whichever section of the network you want to analyze for contingency. So let's just go for the whole system here, and we're going to do with lines, transformers. We know we only have 1 transformer, but we've got 3 generators, and series capacitors and series reactors. We're going to simulate contingency for all these items. So let's go ahead and execute, and we're going to get the message override existing contingency. Okay, yes, and we come up to the second step here. Now this is where we basically set the parameters, or you can look at the contingency here. You can see it's 17 of 17, basically only 17 contingencies compared to 153 if we had selected n-2, and that's going to be a long report to deal with. Okay, but if you are working as a power system engineer, technician, as a grid operator, you're gonna have to deal with all those large reports and ensure that you have a report for every scenarios. Just a quick announcement before we continue. So I recently created basics of DigSilent PowerFactory course on Udemy. This is a good opportunity if you want to study and learn outside of the YouTube platform, where there are no ad breaks or other things, and you can basically set and monitor the pace. And I've included quizzes in this course as well. So I do have some promo coupons for anyone who would like to actually purchase the course at a discount. Just reach out to me and I will pass you the promo coupons. And thank you so very much for your support. And also, if you find this tutorial useful, please make sure you give it a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. Great, let's now close here and check the limits now. So limits for recording. So the maximum thermal limit is set at 80%. So we don't want to go above this limit here. And the lower voltage is 0.95 per unit, and the upper is 105, basically with a 5%, basically 0.05 per unit plus minus. Okay, so if we decrease this here to maybe 3%, okay, or 2%, then here we have to say 1.02, and here we have to say 0.98 per unit. So this will basically be our lower limit, and this will be our upper, and this will basically be our per unit voltage step. Let's now go ahead and execute. Okay, and we have to wait for the system to complete the execution. Looks like it's completed, and when we pull here, we can see that the contingency, calculating AC contingencies, and it's basically done completing the calculation. We skipped the synchronous machine 1. We only did the calculation with synchronous machine 2 and 4, and the lines and the transformers, okay, based on the n-1. Okay, so now we've got data that we can actually analyze, our contingency analysis report. And to do that, we have to go ahead and click on report contingency analysis result. Okay, and here you basically need to select what you want to show on your report, because it's already done the calculations. It's done it for you in the background there. Now what do you want to basically visualize? What do you want on your report? Great. Now as we can see here, DigSilent already pre-selected the maximum loadings, loading violations, and the max and mean voltages. So if you want to add more stuff like the loading violation per case, generator effectiveness, and so forth and so on, that is up to you. Okay, and the maximum loading, as we've already set them in the previous step, so they are already defined here for us. So the next thing is to basically just go ahead and hit execute. Okay, so this will basically just execute the report based on the calculation that was already done down here. Okay, so now we can see here basically case 1. We're going to dive deep in here and try to analyze here all these information that we are basically getting here. Okay, let's go ahead and just cascade them this way so that we can look at them in a most convenient way. Great. Now let's go ahead and do a quick analysis of our contingency analysis report. So clearly we can see we've got problems here on the first one here, the voltage loadings. Okay, so we can see that on the base case and post contingency voltages, we can see we got from 0.873 to 0.95 per unit. Now we know that our absolute maximum limit is 0.95, but the drops here are going down all the way to 0.87, which is a problem. That's why we've got red all over the place here. So the worst one here is the buses D1 REUT all the way to D1 underscore TUB. Here they all are below 0.9. And then we've got D2, D1, and D1 underscore 11A was trying to hold but still went down. And all of these are affected by the contingency on the synchronous machine 2. Okay, so this shows that these synchronous machine 2 have the most impact on our network. Now, what can we do to try to mitigate this? A number of things can be done, because clearly the voltages are dropping. So we can do compensation with reactive power compensation by including things like capacitor banks closely connected to the associated or the affected bus on our system. And adding to the compensation, we can also configure or review the topology around the synchronous machine 2 and explore alternate configuration that will assist us in reducing the voltage drops related to contingency on synchronous machine 2. Now let's look at the contingency loading, basically the overloading of our lines and transformers. Now we set our limit at 80%, but the overloading absolute maximum limit is 100%. Now if you look at it here, all the loadings are below 100%. That's why we can see there is no violation here, although we are above the limit that we set. Okay, and if you look at the transformer through contingency on synchronous machine 4 and contingency on synchronous machine 2, it's very consistent loading. It doesn't change at 85.4% loading with a base loading of 84.5%. And then down here the line went very much almost below our limit here at 83.5, but still okay with a base of 82.4, and that was on contingency of a synchronous machine 4, and that is line underscore TUB underscore DUS loading. So obviously for loading here we are still okay, and the only remedial action that need to be taken is obviously on the voltage that are basically dropping too low below the minimum limit. And down here we can see the maximum loading for our contingency. So for the transformer, the maximum loading is 85.4, and that's happened on the synchronous machine 2 contingency. And for the line, it's 83.5, and that's also happened for synchronous machine 2. Because your loading are still below the 100%, okay, but they are slightly above the 80% that we set ourselves. So if we are concerned about this, we can further redistribute the loading for the transformers or also for the line, maybe erect new line so that we can have less loading on particular lines. Great. Now let's close this report here and go back into our network diagram here. And what can we draw from these contingency analysis here? What can we draw from this? Okay, because there should be some lesson learned based on these contingency analysis. And we can see synchronous machine 2 that have the most impact on our network is sitting down here, and we've got all sort of lines that are connected to it. Great. Now before we can draw some conclusion here, if you find this tutorial useful so far, please make sure you give it a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated, and I thank you so very much. Great. Now, so what can we say in terms of the voltage violation? So we clearly saw there was some voltage concern, especially relating to the contingency on these generator 2 synchronous machine 2. So the concern here is that these buses experiencing voltage drops, right, they could cause operational challenges that we know, such as reducing stability of our system and equipment performances issues. So we need to get down to the root cause of what causing the synchronous machine to basically cause these voltage drops on these buses here, whether we're going to do some compensations with reactive compensation like capacitor bank as we said earlier, or other things that we can do reconfiguration. We need to address that issue because clearly a synchronous machine 2 is having a very severe impact on our voltage levels on our system, and we know that voltage levels are very important for certain power system industries because we cannot afford to supply voltage that dips too way below the standard, below the level that is required. Great. Now what can we say about the transformer loading? Now we saw clearly that the loading was just above the maximum limit that we set ourselves of 80% and below the 100% absolute maximum limit. But we know that for transformer operating at above 80% loading over a long time, it will cause overheating and it will affect its lifespan. So if we hold that into consideration, then we need to find ways that we can mitigate that by probably maybe adding another transformer in parallel here to try to redistribute the load a little bit, although it's below the 100% loading, but still can pose significant problem over a long period. So this need to come into effect in the long-term planning by adding another transformer in parallel. But above all, to close this tutorial, we can clearly see that the synchronous machine 2 have the most impact on our system because it causes massive voltage drops. So we need to go into the deep root of the synchronous machine and try to find out the reason why we're having such massive voltage drop when we run contingency relating to the synchronous machine. So that is it, guys, for this tutorial. And once again, if you find it useful, please make sure you give it a thumbs up and subscribe to CMTEQ channel. If you have a comment, please drop a comment below, any question, and I will address it as soon as I have time. Thank you for watching. Until next time, cheers.